got here, I got a basketball, and I got a tennis ball. Okay? Now what I want you to think about, I want you to think of how I can get this tennis ball to hit the roof with only dropping it from right here. Anybody have any ideas? Great.
Okay, you bounce the basketball and then bounce the tennis ball at the same time and then they like go apart.
Okay, that's not a bad idea. So let's try this. Let's try what she said right here. So I got this basketball. I'm gonna put the tennis ball right on top here, and let's see what happens. All right.
So smart.
Now what we're gonna do today is we're gonna take a look at why that actually works. Any ideas of why that worked? Beck, you got an idea?
The momentum from the basketball after it bounced translates to the tennis ball also. And that's my guess.
Because the basketball is bigger, so it's like heavier.
Okay, good. So it has something to do with their mass and their momentum. Got another little demonstration about the same thing. We got a couple super balls, and you see how the mass goes up incrementally. So what do you think the top ball is going to do when I drop this?
Be like a bullet.
It's gonna go pretty fast, right? So let's see what happens here. I'm not too good at this, so I'd probably watch out if I were you guys right there.
Alright.
Right? So did you see how fast that came up with? Right? So the velocity, was really high. Right? It came off really fast, and I didn't drop it that fast. Right? So momentum probably has to do with what? We talked about first, the differences in mass, and then what was the second one I just said? Velocity, right? So let's examine how mass and velocity relate to the topic at hand, momentum. Right? So, like we said, we saw how the changing in masses, the changing in velocities, resulted in different things happening. So, momentum is the product of mass times velocity. So your momentum is just going to be mass times velocity. That's going to give you a value for momentum. All right, right there, we got that P equals mv. That's one of the equations you're going to need. All right, and the units. The units are going to be kilograms times meters per second. All right, you see that? Because mass is always given in kilograms. Velocity is in meters per second. So we just multiply the two, and that's our units. Now, here's a real good physical application, and I'll show it to you on this graph. So we have another graph here, and as you can see, the force isn't constant, right? It wasn't just a straight line. So let's take a look at what we have to do here. So what we're going to do is we'll break it down into three sections. You see here A1, A2, and A3. All right? Now let's say, anybody here play baseball?
I used to. Yeah.
Used to. All right, how about golf? Right? All right, so say we're playing golf, right? I swing back, and as soon as I start hitting the golf ball, right? This is the point. So as soon as I come into contact with the golf ball, all right, the force is going up really fast, right? Now, have you ever seen those high-speed cameras that slow it down, and you see the ball actually like bend a little bit, and the club bend a little bit, and then what happens? It expands real quickly, and that's how it goes fast. All right. Now this is the part, A1 is the part where it's bending. So when it first comes into contact and it starts bending, the force keeps going up. All right? Where it reaches a point A2, you see how it's constant here? Where for a portion in time, it's going to act like a constant force over it. And then once the golf ball starts moving away, what's going to happen to the force? It's going to decrease because it's going to be in less contact with the ball. Good, Melissa. So that's what this represents. So here we come into contact with the golf ball, the force goes up, it starts bending and molding, and then it's going to start heading out here, and it's going to go away. Okay? So does that help you out with what impulse is a little bit? Okay. So, this guy got 100-pound dumbbells stretched out all the way. That's pretty impressive. Fish, can you do that?
I can't.
100-pound dumbbells. Yes. All right. Fish is the man. So in this picture, he has a big radius. He has as biggest radius as he can because his weights are all the way out. Okay? As you see here. So we got a big R down there. Now his velocity, see how it's like just one circle? He's going to be going around nice and slow. All right? Now, when he pulls it in, what happens to his radius? Right, his radius is smaller. So then what do you think happens to his velocity to?
It increases.
Good. So when this little thing flies in here, his radius got smaller when he brought his arms in. So his velocity went up. His angular velocity went up. He went around faster. So since Fish told me he can hold 100-pound weights in his hand, you want to come up here and help me out?
I will.
Thank you, sir. Now these aren't going to be pushing you, you know, just. So if you would please sit down there, and what I want you to do, I want you to start with your arms out like this, yeah, and just spin around, and then once you get going, bring him in and hold him tight, and let's see what happens to his angular velocity. All right, bring him in. Now did he go faster? Now he's going slower. Do you see him pushing off on anything? No. The only thing he's doing is moving his radius in and out. All right? Thank you, sir.
You're welcome.
All right, can I get a volunteer to read number 1 for me, please? Lacey, you want to read number 1 for me?
Yeah. A 2,200 kilogram sports utility vehicle traveling at 26 meters per second can be stopped in 21 seconds by gently applying the brakes, in 5.5 seconds in a panic stop, or in 0.22 seconds if it hits a concrete wall. What average force is exerted on the SUV in each of these stops?
Okay, thank you very much. Now, we're going to apply the problem-solving strategy we've been using, right? I want you guys to list everything that we know, and then we're going to put down what we're trying to find. So, can I get a volunteer to give me something we know? Melissa, go ahead.
Mass is 2,200 kilograms.
Mass equals 2,200 kilograms. Good. Somebody else, give me something else we know. Lacey, go ahead.
It's traveling at 26 meters per second.
Okay, good. Now, we'll say that's its velocity, and we'll call that initial, right? Because it's initially going at 26 meters per second. So we'll call V1 equals 26 meters per second. All right? Somebody else give me something we know. Lauren.
Time 1 is 21 seconds.
Okay. So we have what? We have 3 different times. So time 1 equals 21 seconds. Keep going, Lauren. You got them all.
Time 2 is 5.5 seconds. And then time 3 is 0.22 seconds.
All right, good. So these are the 3 different kind of stops we're going to look. If you gently apply the brakes, if you jam them on, if you see a wreck in front of you, you have to jam them on, or if you wreck into a concrete wall. All right. So this is good. Pay attention here. So you'll find out why you don't want to wreck into a concrete wall, because I know you all are drivers right now.
Good.
So there's one more thing we know. What is it? Now, if I wreck into a wall, what's my final velocity going to be?
0.
Good. So my velocity 2 equals 0 meters per second. All right. answer. Raise your hand when you have the answer.
We all got it back here.
All right, what do you got? What do you got?
24 and 2/3.
24 and 2/3.
meters.
Point 2/3 left.
Nice, you get the same thing?
Yeah.
All right, good, sounds good. So after the wreck, they're going to be moving
Point 2/3.
24.6 meters per second together. So after they hit, they're going to mold together, and they're going to go 24.6 meters per second. You remember that basketball and tennis ball equation example we were looking at? Now, knowing that, I want to prove that the tennis ball is going to have greater velocity. All right? So now we know all the equations, and we know that momentum is conserved. We can prove that the tennis ball will be going faster. So afterwards, right, we'll look at it. Did the basketball have a lot of velocity upward?
No.
Not at all. So let's say it's 0. Just to help us prove it a little more, it was so small that we can just say it was 0. Okay? Right? It only came off the ground just a little bit. Alright? Because if I normally bounce the ball, it comes almost all the way back up, right? So comparatively, it had about 0 velocity. Alright, so we'll use that. Okay, so you just prove that's going to happen, and we physically saw it happen, and then then we just proved it. So for homework, all you have to do is you're going to take a look at number 3 on the practice problem worksheet. Okay. Again, remember we're probably going to use. There's a star by it. All right, star that. And then we're going to take a look at some more impulse questions and stuff like that in a lab tomorrow. Any questions?